Assalamu alaikum. Welcome to my video series on data science. In today's lecture, we will be discussing about the first step of the data science process, that is problem definition. We will learn about the key components of problem definitions with three examples. Let's talk about the key components in problem definition. Number 1, problem. Identify business or the research problems that needs to be solved. Number 2, objective. You have to clearly state the desired outcomes or goals of the project. Scope. Define the boundaries of the problem, including the relevant data, tools, and stakeholders. Constraints. Identify any limitations or restrictions such as data availability, computational resources, or time constraints. Last and the most important thing, metrics. There should be a metric to measure the success of your project. Let's understand problem definition with several examples. The first example is detecting defects in manufacturing. So what is the problem? A factory needs to automate the detection of the defects in the products using images from quality control cameras. Objective. Build an image classification model that identifies defective products with 95% accuracy. Scope. Use high-resolution images of products from the assembly line, focusing on common defects like scratches and cracks. Constraints or limitations. Limited label data and variations in lighting conditions during image capture. Metrics. Measure success using accuracy, recall for defect detection, and reduction in manual inspection costs. Previous example used image data. This example uses textual data. And the project is sentiment analysis of customer reviews. Problem. An e-commerce platform wants to analyze customer reviews to gauge sentiments towards their products. Objective. Create a sentiment analysis model to classify reviews as positive, neutral, or negative with 90% accuracy. Scope. Focus on English language reviews collected over the past year, ignoring other languages for now. Constraints. Data may contain slang, abbreviations, and misspellings. Limited computational resources for real-time processing. Success will be determined by accuracy, F1 score, and the model's ability to identify trends in the customer feedback. Now let's talk about tabular data. Predicting and analyzing course performance. An instructor wants to analyze the performance of their course and predict the final grade of students based on their assessment to date. Objective. Develop a predictive model that forecasts students' final grades with 90% accuracy to identify at-risk students and improve the course content. Scope. Use student data, including attendance, assignments, scores, participation, and the midterm grades from the current and the past courses. Constraints. Incomplete data from students who joined late and variation in teaching methods between the semesters. Metrics. Success will be measured by the model's accuracy, precision, and the ability to improve actionable insights for course improvement. In this video, we'll discuss about the key components of the problem definition along with different examples. In the next video, we will be discussing about the data collection process. Thank you for your time and see you in the next video.